On the edge of Saturn's rings sits one of the strangest objects in our solar system. Enceladus is tiny, barely the size of Arizona, and its icy surface reflects nearly 90% of the sunlight that hits it, dropping its average temperature down to a brutal -200 degrees Celsius. By the strict rules of planetary physics, a celestial body this small should have lost all its internal heat billions of years ago. NASA expected to find a completely frozen, inactive world when they launched Voyager 1 and 2 to the outer solar system in the early 1980s. Instead, this mapping diagram of Enceladus reveals a glaring physical anomaly. The northern hemisphere is heavily scarred by massive impact craters, but down in the southern hemisphere, the surface is completely flat and smooth. Since asteroids do not selectively avoid one half of a moon, some kind of active geological mechanism has to be wiping those craters away. Enceladus orbits precisely within the densest section of Saturn's faint blue E-ring. Astronomers knew this ring was packed with microscopic ice grains, but ice particles crash into each other and degrade over time, meaning the E-ring requires a constant active source to replenish it before the particles vanish. The initial working theory suggested Enceladus was shedding its own surface to supply the ring. However, that hypothesis failed to explain why the moon would only lose material from its southern tip, while the north remained cratered and old. A telemetry photograph taken in 1980 revealed a detail that went unnoticed for years: a faint, unexplained tail of material bleeding off the edge of the moon. The missing craters and that steady stream of material confirm Enceladus is an active participant in Saturn's system, constantly pumping its own mass into the surrounding space. To solve the mysteries left by Voyager, the Cassini spacecraft arrived at Saturn in 2004. It immediately focused its suite of instruments on the moon's southern polar region. This thermal map shows what it found: 4 deep tectonic fractures, known as tiger stripes. The fresh ice packed inside them registered at -128 degrees Celsius, brutally cold, but a massive heat spike compared to the rest of the frozen surface. To check if these cracks were venting gas, scientists watched a background star pass behind the moon, creating a miniature eclipse. This graph shows the starlight intensity dropping as it grazed the southern edge, proving the presence of a localized water vapor atmosphere. Those tiger stripes are actually massive cryovolcanoes. They are constantly blasting millions of tons of frozen slush into space, burying the local impact craters in fresh snow while feeding Saturn's E-ring. But this creates a new paradox. How is a rock the size of Arizona generating enough internal power to fuel massive ice volcanoes? Look at this orbital map. A gravitational tug-of-war with a larger moon forces Enceladus onto an elliptical path. Because its distance constantly changes, Saturn's gravity repeatedly stretches and squeezes the moon's rocky core. That constant friction generates internal heat through tidal heating. Cassini also detected a tiny wobble, or libration, in the moon's rotation. If Enceladus were a completely solid block of ice and rock, that physical movement would be mathematically impossible. The only way the outer ice shell could possibly move independently from the core is if it's floating. That wobble confirms Enceladus contains a massive global ocean of liquid water right beneath the crust. NASA immediately rerouted the Cassini probe to dive straight through the violent geyser plumes to sample the water. Its instruments detected salt, which proves the subsurface ocean has spent billions of years dissolving minerals directly from the moon's rocky core. The probe also identified complex organic molecules. These are the essential chemical building blocks required to form amino acids, the foundation of life as we know it. This cross-section illustrates the moon's internal chemistry. Cassini detected microscopic silica particles in the ice, a direct chemical signature of deep-sea hydrothermal vents. Here on Earth, hydrothermal vents at the bottom of our oceans support thriving ecosystems in total darkness, relying entirely on chemical reactions rather than energy from the sun. With liquid water, the right chemical building blocks, and a steady internal energy source, Enceladus is officially the most promising habitat for life beyond Earth. To protect this pristine environment, NASA ended the mission in 2017 by plunging Cassini directly into Saturn's atmosphere. They destroyed a multi-billion-dollar probe to guarantee that hitchhiking Earth bacteria would never contaminate Enceladus, preserving that pristine alien ocean for the day we finally return to explore it.